So, here we are again. You know, I've been thinking, why is this thing so angry?
Maybe he's just hungry.
I'm not going in there to feed it. No, this seems like something very primal.
This is kind of a hard one, because we don't really have any biological definitions for emotions like anger. Sure, brain imaging studies have shown that some brain regions are more active when people are angry, but these are almost always correlational. When it's warmer outside, people wear less clothing, but if I strip down to my birthday suit, it doesn't make it sunny.
It's like having someone run on a treadmill and saying, "Look at how much more his arms move when he runs faster. The arms must be where running happens."
That's why working with people with brain lesions is so important to neuroscience. It adds some causal evidence that a brain area might be required for a behavior. The same with brain stimulation studies. If stimulating a brain area causes a behavior, then that's good evidence that the brain region is involved in that behavior. So, like studies with cats in the 1950s showed that stimulating a small almond-shaped area deep in the brain, called the amygdala, leads to aggressive or predatory behaviors. These things look pretty aggressive to me.
Right. But other studies have shown that stimulating different parts of the amygdala can actually suppress predatory behaviors. So it's kind of a complicated little brain structure.
Yeah, and fMRI studies have found that the amygdala is active in violent criminals.
Whoa. Careful there. Just because criminals have the same active brain regions as people who are angry doesn't mean that they're inherently aggressive. That's like saying because I kiss with the same face hole that I use to burp, then these two things are related. It's a false equivalence.
Huh. Never thought of it like that. That's a good point.
You know, the amygdala is part of the Papes circuit. This system was discovered by James Papes, who used the rabies virus to lesion different areas in the cat's brain. He found that the amygdala was physically connected to another region called the hippocampus, a little seahorse-shaped area that is needed to turn short-term memories into long-term memories. It's thought that this connection between the amygdala and hippocampus links emotion and memory together, so that you remember really emotional stuff better than boring everyday things.
Yeah, like patient HM. In the 1950s, surgeons removed both his left and right hippocampuses to treat his epilepsy. But after the surgery, he couldn't remember any new information for longer than a few minutes. Zombies appear to be pretty forgetful, wouldn't you agree?
Absolutely. Between the amygdala-related aggression and memory deficits from the hippocampus, Papes may have actually accidentally created the first zombie cat.
Aw, come on, Meow. Let's not get carried away. But now we do have some testable hypotheses. I'd put money on its aggression and memory problems being linked to abnormalities in its amygdala and hippocampus, respectively.
Great. So all we need to do now is figure out how to experimentally test this. Do you think it'll let us examine its brain to verify our hypothesis?
I think I might be more comfortable not knowing the answer to this one.
Maybe we could get a graduate student to do it for us?